Right. So, how did the homework go? It went? So, what was the challenge with it? Huh? Submitting it to GitHub? Really? That GitHub's still a problem?
A little bit.
Really? What's the challenge?
It shouldn't be anymore, but yeah.
You're still using the plugin.
Yeah, I tried using the terminal, but I can get that remove icon thing to work.
Didn't that just sound like it was air? Can I just open it? This is a bottle of water. A student gave this to me. Even looks like it's bubbling. You see that? Tastes like water. It'd be funny if it was a Sprite. All right. Okay, so GitHub through the plugin. Were you trying the plugin or the command line?
No.
So that was a challenge as well?
Yeah, it was giving me an error that my credentials were going through.
Okay. Did you eventually get it?
I am going to continue to
Okay. Well, if you need help, let me look at it and I can get you straightened out. Let's see. You're still having problems? You're not able to repeat my steps perfectly? All right, we'll look at that. Now, in your defense, GitHub is one of those things that takes a little practice to get used to. And once you're used to it, then it becomes easy, second nature type stuff. But until you get used to moving yourself into the directory where your source code is and adding it to the current repository and then committing it and then doing the remote post or the remote push, until that becomes kind of second nature, that whole workflow, then. So my guess is you're either A, not moving into the same directory as the stuff, forgetting to add it to the repository, forgetting to commit. So there's those three things that have to happen before you can actually do a remote push. You only ever have to do the remote add once the repository is added, and that's going to deal with your credentials. So if yours is messed up there, what we might end up doing is just removing that remote repository, then recreating it, which will then have us put the credentials in again, because it does try to remember who you are. So it's possible if you typed in the password wrong one of the times, or maybe a bigger danger here on campus is somewhere in the middle of it, the internet dropped out. Something could have zigged when it should have zagged or something like that. So do let me know, because actually I know it maybe seems kind of like a headache, but part of what I'm teaching you is using that tool because it is an industry standard tool. I think I've mentioned to some of you guys when you start applying for internships and stuff like that, they're going to ask that you provide them with your GitHub link, or that's one of the options you can give them is your GitHub link. So this isn't something that's going to be very specific to this class. GitHub is like an industry standard thing you will use in any sort of software development company. All right, so it's a tool that you do want to get used to one way or another. And like I said before, the reason I like the command line version of it is with that, it doesn't matter what software you're working on. Otherwise you have to learn the Eclipse plugin for it, the Xcode plugin for it, which I actually do use. I think I've mentioned I use the Xcode one because it's just well done. The Visual Studio version of it. You have to learn all these different plugins, otherwise you can just learn the one command line thing and just do it whenever you need it. And eventually what ends up happening is you can create your own little scripts to do this. So for instance, like if I give you an example of that, let's just go into the terminal here real quick. All right, and let me close a couple of things here. So this is kind of where I would recommend all of you start moving towards. I'm going to open up Eclipse. Let's see, that's that. We're just going to get into the directory we were in. What class is this? 300, there we go. And just in case I haven't made a change, I'm going to just go ahead and put a private node tail at the top of my linked list. We're going to end up using it here in a few minutes. So I saved all that. Then I'll go in here to the source directory, right click, say show in System Explorer. which will give me that as a directory. Then I'll type cd space, so again, if I type pwd, this shows me where I'm currently sitting in my file system. I want to change directory, so cd, into the directory where that source is, so that when I type in ls, I see my .java files. ls.a should show me that I already have a Git repository in there. Okay, so now I'll say git add star.java, git status will show me what's changed. You don't have to do the git status. That's more for us visually. All right, then git commit. Commit -m, added tail. All right, and then finally git remote push origin. Is that right? So first of all, you're starting to see I'm using some command line stuff that's reasonably powerful. There's the history command I was showing some of you after class last time, I think, that shows me all the commands I've ever typed in. I can do history, pipe the output of that, that's the pipe command, to the grep command, and I'm going to grep on git remote, which then shows me the remote thing. So where's my remote push? So we've already added. Oh, actually, it's just commit. It's just push, not remote. So that's the command I want to do, right? So I can either copy that or I can hit bang 499, which was the... You missed a quiz. Are you sad? All right, so notice here it's my 499th command here in the history. So I can either just copy it and paste it, or I can just say bang 499 like that, exclamation point, and it'll do that command there. Okay, I'm going to go ahead, though, and just copy this real quick because I'm going to need it here in a second. Okay, so that just did a remote push. But now what I'm going to do is I'm going to create a little file here in this directory. Okay, so I'm going to say vi git push. That's fine. So I'm going to create you can use this in Notepad if you want. And what I'm going to do is I'm going to put a couple of my commands in here. So I'm going to say git add star.java. Then I'm going to say git commit -m made a change. So this is the one piece that it's going to have to be relatively generic if you do it inside of a script. Then finally, I'll do my git push u origin master, like that. So I put all three of those commands in there that I'm going to need for making an update to GitHub. So I'll go ahead and save that. So if you did that in Notepad, you would have just saved it to this directory. So you see here I have, when I type ls, I have 4 files now, my 3.java files, and then this file called git push. And I'm going to go ahead and change the mode of git push to be 755, which means it's executable and read and, well, actually I just need it to be, doesn't matter what we make it. 755, read and write by everybody in the group or whatever. So this changes the permissions for read, write, execute. This is, the first one is for the owner. The second one is for the group. Is that right? And the third one is for everybody. So if I want to just give the owner of the file access at all, I can make it 700. 7 means read, write, execute. 5 means read, write. 3 means read. 1 means write, something like that. but 755 kind of is kind of a default thing. That way other people can see it. So I'm going to change the mode of this so it's executable by the owner. All right, so now I can actually run that command. Okay, and let's see, it tells me everything's up to date because I didn't make any changes. All right, so I'll go ahead and make a quick change. Let's go into Node. And in Node, we're going to create another variable, private node prev node, right? So first two steps for our assignment. So let's say now that we're done for the day. After we've saved everything, we can just go back out to the terminal, run git push, and we're done. That makes sense? So you put those steps inside of a little script, and now whenever you need to do it, it's one little command. Took all of, what, 2 seconds to do it after I wrote that script. And all the script is in a command line is the commands you need to do in order. And then you just make the file executable. If you're on Windows, you might just name the file something.bat, B-A-T. That's a batch file that'll automatically become executable. .exe might work, but I actually think it won't because it'll treat it as a binary file. So you want to name it something.bat. That's a default executable file in Windows, but it's a batch file, so it just goes through linearly. It's a set of commands. That makes sense? So once you learn your magical commands you need to type in to make yours work, which should be these commands, but once you got them down, put them in a script, and then you can just run that script whenever you want. And then when you start working in another folder, you can just copy that script over, because this is just working locally in that folder. That makes sense? Because I stored this in the folder where all my .java files were. So I have a little file here called git push. Okay, so one thing I kind of want you to get out of these lessons is actually how powerful the command line is. It's a tool that a lot of modern day computer science folks don't get because we're so used to working with GUIs all the time. Okay, but like I said, if you have some other questions, I can look at it after class today, or if you have to run, come to my office. I'll be here. I'll be sitting in my office actually a good chunk of today. The senior seminar is not meeting, so I'm just going to basically from 1 p.m. on until I decide to go home. I'm just going to be here. So swing by and I'll help you get it figured out. Because it's not hard, but it is one of those things, since we're not used to working with command line, it's one of those things that becomes a little intimidating and a little frustrating when it's one little stupid thing you're missing and you're not experienced enough at working with the command line to catch it. So I'm happy to help. Whatever. All right, make sense? All right, so let's go through and let's look at what we needed to do for this assignment. Now we had, so the whole point of this was to do our display in reverse, correct? But you had to update a bunch of other crap?
Yeah.
So your evidence was this works. By you rewrite this in such a way that you're using previous nodes, start at tail and walk to previous nodes. So if we go ahead and rewrite this right now, we can just say node cur node is equal to tail while tail dot, oh, I need to write the get previous node. So here, we'll come back and write this. We'll just leave it for right now. But the idea here is you would, well here, let's just go into node real quick. We need to create a getter and setter for previous node, correct? So we added a new field. So that's a instance variable to our class node, private field called prev node. We need to have a getter and setter for that guy so that we can ask for that private field, and we can also set that private field. So I'll right click here, and we're going to go to source, generate getters and setters, and we're going to do this for prev node. Notice that for payload, the only thing we have is set that we haven't done, because we don't want people to externally be able to change our payloads. That's actually historically been kind of a cop-out for linked lists. Rather than rehook up different things, just go in and swap the payloads. Make sense? It's a cop-out. Don't do that. People will lose respect. All right. Because it only works when you have primitive types like this. If you start storing a linked list of more complex data types, swapping them out on pointers can start actually causing some other issues if you have more than one thing pointing to the same place, and you don't want to do that. You actually want to move nodes around. So we're not going to add that particular setter. So instead, we're just going to go and we're going to add a get previous and a set previous for our payload. And those are going to be public, so we'll hit OK. And now they're in there. OK. So we added those two guys to node. So we'll go back to linked list now, and now we'll be able to. So we're going to say while kernode dot get next get previous node, sorry. Previous node is not equal to null. And I realize we have that count, but I kind of prefer walking it via memory like this, but whatever. Whatever makes you happy is fine. We will say system.out.print kernode.get payload concatenated with, and what do we do? Okay, arrow like that. Actually, was it no spaces? No spaces. So just like that in there. And then in the end, we would say system.out.println null for our last guy. And then each time through the loop, we're going to say kernode is equal to kernode.get prev node to walk the list backwards. Okay, so when all is said and done, this code should display our list in reverse, assuming we made all the correct new wire hookups. Make sense? Okay, so now what we need to do is we need to do a pass through each of our add methods and each of our remove methods and update them to use tail. Make sense? All right, so let's get rid of some of these comments. So let's start off with the add front and add end, our simpler cases. So, and actually add end gets a lot easier. So add front, and actually, sorry. When we first create our linked list, head will be null, and tail will also be null. Head and tail both point to the same place. Okay. You could also, if you want to have this kind of make some logical sense, you can say head is null, tail points is the same thing as head. Those are all equivalents. Okay? So I would still probably write it as null and null. So that's what an empty linked list looks like. When we're adding to the front, we also need to update something else. Inside of node, when we first create a node, and let me move these guys down below the constructor, if you'll let me. When we first create a node, we set the payload equal to whatever's passed in. We default next node to null. We also need to default previous node to null. When a node is first born, its next node and previous node point nowhere. Make sense? Okay. So now back in linked list, when we are adding to the front, we'll create our new node right here that will by default have a next node and a previous node both equal to null. If the head is null, if this is the empty list, we'll make head point to this guy. We will also need to make tail point to this guy. Correct? If we have the empty list and we add one thing to the list, the head and tail are both the same dude. Okay? Otherwise, if they're not the same dude, we're going to set end's next node equal to whatever head is. And then we'll set head equal to end. Make sense? But we need to update one additional thing there. we need to set n dot, I'm sorry, not end. We need to see head dot set previous node to n. So when we're adding a new node, we're going to have our new node's next node point to whatever head currently points to. Then we're going to have our head's previous node point to our new node. Then we'll have head point to the new node, which is the front of the list. That make sense? Let me draw a picture. I'm getting some glazed looks.
You set head to n and then set n's next node to head.
Well, I don't know yet. Hold on. All right, so right now I have something that looks like this. We have head is this, and we have tail is this. And then I need my arrows, right? Love the arrows. So right now, head and tail both point to the same place. All right, so now we bring a brand new node in. So let's say we're adding a 7, and we're adding this to the front. So the very first thing our code says to do is set n's next node to head. So n, our new guy, his next node is going to point to head. And this guy also has a previous node that's currently pointing nowhere, just as this guy's previous node is currently pointing to null, right? Because every node has a next node and a previous node. So we can draw those in now. So this is our original list. The first thing we're going to do is we're going to take our brand new node, we're going to create it. And when we first create it, its next node and its previous node both point to nothing, to null. So the very first thing we're going to do is we're going to take n, that's this guy, that's n. We're going to set his next node to point to the same place that head points to. That's that line right there. Then we're going to set head's previous node to n. So here's head, which points there. This guy's previous node, which used to be null, is now going to point to n. Then we're going to set head equal to n. So head points to the new front of the list. This guy's previous node is null. This guy's next node is what used to be head. What used to be head's previous node is now the new n, and this guy's next node is null. Tail still points to where it used to point. Does that make sense? Okay, now you asked, couldn't I do what?
Head set previous node to n, and then n set next node to head, and then head equals n.
Oh, so you just want to flip the two lines around.
Yeah, kind of.
Same lines though, is it?
Are they?
Not kind of, is it? You said head set previous node to n?
Yep.
You just did these lines backwards. Yeah, that's identical. Because we didn't lose pointers.
Yeah.
Right? That's the only thing that's important. When you draw your pictures, just make sure you don't drop a pointer. Okay, so he just wanted to set this guy's previous node from null to our new node before he set our new node's next node equal to this guy. Doesn't matter. Doing the exact same crap, just in a different order. All right, does that make sense? So that's add front. So add front gets a little bit more complex just because we have to add one more pointer into the equation. We need to make sure that next and previous both point to the same place. Okay. Other than that, this guy's pretty easy. So that's add front. Now add end actually gets easier. So if we have nothing, actually hold on, so up here we had head equals n, tail equals n. in here, if head is equal to null, then we can set this dot head equal to n, this dot tail equal to n. So exact same thing. So if we're adding to the end of the empty list, head and tail will both point to the same place. Otherwise, this is where we get into this stuff. And now we can gut this. We no longer have to traverse our list. So this is the first example of where tail really helps us. We know exactly where the end of the list is. So back to this picture here. If now I'm adding a, let me grab Epic. So this is 3. All right, so this is the new node we're adding. We want to add it to the end. What do we need to do? We need to go to tail. This is this guy. And we're going to set this guy, tail's next node, equal to n. Right? So that's step 1. So tail dot set next node equal to n. Then we'll set n's previous node equal to tail. N dot set prev node to tail. And then update tail to point to our new end of the list. Tail is equal to n. Okay? So do we see now how add end actually just became a little easier? We no longer had to traverse because we could just go to the end of the list. Make sense? So that's add end. So we still have our, actually here we forgot to update that visually. The code says the right thing. Sometimes my pictures drag behind my code a little bit. It's a compile time problem. Nothing. I hate you guys. I am a more skilled coder than I am a drawer, but I'm aspiring. See, look at that. That looks legit.
I made a drawing too.
Huh?
I made a drawing too.
How, is yours better than mine? I don't want to see it. I do all my drawing with Keynote because I know how to use the shapes button.
Let's go back to the code.
Yours is totally better than mine. What program is that?
Google.
Oh, it's basically Google's Keynote version, their
Yeah.
presentation thing?
Google Draw.
No, mine's better then.
Can we go back to the code?
No.
Please.
You don't understand code.
I know, but can we try? I want to try. Introduce.
All right. This guy?
Yeah.
Now, it's important. Don't just copy this. I want you to understand how this is working.
No, I have it. I just have something set a little different. I want to write first so I can.
Okay, I got it. I got it. Because you're my pet project this semester.
I obviously didn't know how.
I did hit record. Yeah, there you go. Look at that. I can't even read my phone because of my shakes. Isn't that terrible? I know. Over 2 years now I've had these. Too young. Too young for that. What was
That didn't sound
that? When you just stretch your arm out, things aren't supposed to move that much, are they? All right.
I thought I heard a pop.
Yeah, it was a pop. It was good.
Trying to dislocate your elbow?
Maybe that would help. There's probably a pinched nerve in there or something. They've done all the other blood tests. They don't know what's wrong. And I had my brain tumor test the other day, and the doctor hasn't called me screaming, so I assume that's...
I'll call you next week.
Unless they just gave up hope. I don't think it's what they tested me for isn't like a dangerous, well, I assume there's not such thing as a good brain tumor, but it's like something in the pituitary gland that like throws off your hormones or something. I don't think it's like something that they're like, it's like you're dying of cancer type thing. But who knows what they'll find? You never know. All right, you're good? All right. So that's add end. Cool? Add an index. If we are less than 0, add front. If we are greater than or equal to count, add end. We don't need to mess with those, right? Because add front and add end, we just updated those. They do what they're supposed to do. They're perfect. I haven't tested it yet. I would recommend that you not go by that logic, but I'm feeling lucky today. Else, we go down here and we do the what if it's somewhere in the middle stuff. All right, so let's go back, draw our picture. So now we're going to add this guy. Let's see, can I get all that? So we're going to add a 1. So here's our new node n, and we want to add it at bucket 1, let's say. We want him to be the new bucket 1. Okay, so this guy will become the bucket 2. So what are we going to do? Well, right off the bat, we need to walk to the bucket we're interested in. So I'm actually going to do this a little bit different than we did before. So we'll create a brand new node n. So in our example here, that's the 1. We'll set cur equal to head. And now we're going to walk all the way to our index, not 1 before. Okay, so this for loop will take cur to the point in our code. So that's where our index is. So cur starts off here at 0. We're going to 1. Is 0 less than 1? Yes. So cur gets set to his own next node. Now it's 1. Is 1 less than 1? Nope. So we're exactly where we want to be, right? So cur points to the node we want to replace or reposition. Reposition is maybe the better way of saying it. All right, so we're in this situation there. So after this for loop, cur is pointing to the guy we are moving. And what do we need to do? We need to insert this guy in place of this guy. So we're going to set ends next node equal to this guy. That looks like a safe move. Okay, so let's go ahead and do that. So we're going to come here and we're going to set ends, set next node equal to cur, just cur. Okay, we're going to have ends next node point to the same place that cur points to. That's this first line. And here I'm just going to take out the second line. All right, we've done that. Ends previous node should point where? To the same place as cur's previous node points. N dot set previous node is cur dot get previous node. Make sense? So those are the first 2 lines. So we haven't changed anything with our original list. All we've done is we've taken our brand new node n and kind of hooked it on. Okay, we made n point to have his next node point to the guy that's going to become the next node, and then we had n also have his previous node point to the same place cur's previous node currently points to. Okay, so now we've maintained pointers to these 2 places. So now we can set cur's previous node equal to n. Cur dot set previous node to n. Now we look like this, and finally we can set n's previous node's next node equal to n. N dot get previous node dot set next node equal to n. N dot get previous node dot set next node to n. And that gets us here. You didn't like that move? Okay, so here's n. Here's his previous node. We're going to go to his previous node, and we're going to set his next node to n. So that's the line that looks a little intimidating. N dot get previous node dot set next node to N. Okay, so the N dot get previous node, all that does is says get this guy. And then if you say I have this guy, now set this guy's next node to N, it's less intimidating when you think about it in the two separate pieces like that. All right? We didn't change head at all. We didn't change tail at all. All we did is we inserted this guy at bucket 1. So now we have head points to 7. 7's previous node points nowhere. 7's next node points to N. N's previous node points back to 7. N's next node points to 5, which used to be at bucket 1. 5's previous node points back to N. So we got our doubly linked list hooked up right. Looks legit. All right. All right, so those are our add methods. All right, now we got some delete methods. Oh my gosh, look at that. Remove an index. That's going to be nasty. All right, remove end. So if head is equal to null, throw an exception. Can't remove anything from the empty list. We'll leave that alone. If count is equal to 1, let's call remove front. So actually, let's just do remove front first then. So again, empty list, can't remove anything. Otherwise, to remove front, what do? Well, let's look at our picture. If this is my list and I want to remove front, I need to go to head. This is the guy we're taking out of here, right? So I need to take this guy. Ultimately, we want his next node to point nowhere. But before I can do that, I need to go to this guy's next node and have his previous node point to nothing. Make sense? I need to disconnect that. So I'll say, let's actually get rid of this cur node stuff for a second. So I'm going to say head dot get next node dot set previous node to null. So that's this move right here.
That wasn't part of the homework though, right?
I don't know, what did I tell you to do for the homework?
Just, I think it was just mess with the add ones.
Yeah.
Is it add and removes? I don't remember what I asked. What did I ask?
Pretty much has
Oh.
to just add everything.
Let's see.
So you sucked?
Yeah, I didn't do the remove methods.
All right, so I should keep going?
Yeah.
All right. Look, I just work here, people. You think I remember what I said last Thursday? I don't remember what I said 2 hours ago. All right, so we're going to start off at head, go to his next node, and set that guy's previous node equal to this guy. All right. Now, if we are in here, if head's equal to null, we're doing this. Now, what if the head is the 1 list? This won't work, will it? So, else if this dot count is equal to 1, do what? We're going to we're just removing a payload, right? So int payload to return. Oh wow, that was interesting. Payload to return is this dot head dot get payload. Then I can say this dot head is equal to null. This dot tail is equal to null. So now these guys point nowhere, right? We're back to the empty list, and we always count minus minus. And then we will return well, I'll just put it inside here. return,
Inside there?
huh?
Do you need to put it inside the if?
I do. So I need to decrement count. We'll move stuff around after we have the logic written. So if we have a count of 1, then we're going to go ahead and preserve the value we want to return, set head and tail equal to null, decrement count, and then go ahead and return the dude, right? We're basically returning our list back to the empty list. We could have also just said this dot count equals 0 if that made us happier. We basically are doing the exact same stuff that's in our constructor. All right, so empty list, can't remove anything. One list, we're setting it back to the, here, we'll even do the equals 0 thing. One list, we're setting it back to the one list, or the empty list rather. Otherwise, and we don't even need to put that in else if we don't want, but let's do it. Logically, I think it makes reasonable sense. Otherwise, we know head has a next node, and we'll set that guy's previous node to null. So we're back at this picture. So we went to head, got to his next node, and we set that guy's previous node to null. All right. Then we're going to set head equal to what? Heads get next node. Now, if you want to go by what I said last time, I personally like disconnecting these things. I like leaving this guy completely disconnected for my own personal preference. So, given that, I would probably rate it like this. Node cur is equal to head. Cur dot get next node dot set previous node to null. Then I would say head is equal to cur dot get next node. So initially I had cur and head both point to the same place. Then I said set head equal to cur's next node. So I did this. That's the new front of my list, right? And now I still have access to this guy. So I could set cur's next node to null. Cur dot set next node to null. And then this dot count minus minus. Yep, and then finally I could say return cur dot get payload, because that's the guy we just removed. Make sense? Many programmers would call this overkill, but hopefully you're seeing my pattern. I like to be very explicit rather than rely on garbage collection to, in general, I tend to have an aversion to anything that does stuff for me automatically that doesn't necessarily make clear sense why it does it automatically for me. I like to just clean up my own mess, if you will, rather than relying on garbage collection to do it for me. So in the state I've left this guy in right here, even if the garbage collection doesn't clean that up, I've done no harm. I've wasted a little bit of memory here, but I haven't left some random pointer to another node in my list. Okay? And this is strictly personal preference, because that last thing there was really a waste of time. Garbage collection, I promise you, would have cleaned that up. As soon as that method ended, and we no longer had anything pointing to this guy, garbage collection would have gotten rid of that guy. I just like disconnecting. Complete personal preference. Plus, it makes my pictures prettier. Because when I'm done, I can just do this. I can take this guy. I can drag them all the way over here. Uh-oh. I missed it again. Are you serious? So now it's clearly he's no longer attached to that list, right? So now we see who's been removed. Perfectly pretty picture. Better than your picture.
And it has a random pointer.
Where? Have a random pointer?
Yeah, look up. Straight above your arrow.
It's not a random pointer, it's pointing to null.
This guy? Yeah, points to null. That's the new head of the list.
Oh, okay.
Yeah, that's accurate. Yeah, all my linked list pictures are anatomically correct. I got nothing from that one too. Man, tough crowd today. Okay, so that was, what did we just write? Remove front. So now we got to do remove end. And I did them in that order because remove end is done in terms of remove front for the one list. So now we handle the empty list right there. We handle the one list right here. Now we go to our else for our end. I'm just going to delete all this crap. All right. So what do we do if it's not the empty list or the one list? Well, we're going to that guy's been garbage collected. We're going to make cur point to the same place tail points to. Let's start off with that. Node cur is equal to tail. Then we know ultimately we want this guy to be disconnected, right? We're removing that guy. So now we can set tail equal to cur's previous node. Tail is equal to cur dot get previous node. Okay, then we're going to set cur dot set previous node to null. And then we're going to set tail dot set next node to null. So we have this guy sitting out here nowhere. We know he's completely disconnected. Only thing that points to him is cur, and cur dies with this method's over. So the last thing we have to do is return the payload associated with cur and decrement our count. So we'll say this dot count minus minus, and we will return cur dot get payload. That makes sense? Now, notice that our methods are having substantially less traversal in them, because now we can just jump to the end. The only time we need to traverse is when we're going somewhere in the middle of the list. And we could even make that more efficient by saying, okay, well, depending on the current count of the list, should we start at the beginning or start at the end in terms of getting to the position we're replacing? Okay? So we could add some efficiency to this that way. We're not going to waste our time doing that, but we could. If you have a list of 10 million elements and you are replacing, the guy right before the end of the list, it would probably be in your best interest not to start at head and traverse all the way there. You'd be better off starting at tail and traversing back one. Make sense? All right, so that's remove front, remove end. Lastly, we're at remove at index. So what do we want to do? Well, if it's empty, yell. If it's less than 0, or greater than the count, well, there's our other exception. So that's when we introduce exceptions, right? Otherwise, it must be somewhere, well, no. So otherwise, that's if we have an exception. So we can say else if index is equal to 0.
We do that in the next one.
Oh, do we? Oh, thank you. All right, so else we're removing something. So if the index is 0, remove front. If the index is the last legal one, remove end. Otherwise, we're removing somewhere in the middle. So we're going to start cur node off at head. We'll traverse to the actual node that we want to get to. I is 0, I is less than index. So that's going to do this. Let me give myself a list back so I have some stuff. All right, so let's say that we are creating, here, let's go back one more level. Good there? Okay, so let's say we're removing this guy. So this is 0, this is 1. So we're going to remove whatever's at bucket 1. So first, we need to traverse our list to bucket 1, because that's where we want cur to point to. So I is going to start off at 0, as long as we go less than index, so we're going 1. So is 0 less than 1? Yes. So cur will go from head, because it'll start off at head, move to head's next node. 0 becomes 1. Is 1 less than 1? Nope, so we're done. Cur's positioned where we want it to be positioned. That is, he is pointing at the dude we're getting rid of. All right, so that's what this code right here does. It makes cur node point to the guy we want to get rid of. And I'm going to just get rid of this code here, because we'll do the logic now. I always find that easier. Rather than trying to duct tape the code you already have, I like to just erase the chunk of code, because especially in a situation like this where our logic is likely to change a little bit, I'd rather not fix old code. I'd rather just rewrite new code. So now we're stuck with this, and what we ultimately want to do is we want to disconnect this guy, which is no longer called in. The only thing it points to is cur. We want to disconnect this guy from our list, making this guy's previous node point to this guy's next node. Right? Okay, so we're going to take this guy dot get previous node dot set next node to here. Fair enough, first move? So we're going to say cur dot, oh, it's called cur node in here. Cur node dot get. What did I say to do?
Get previous node.
Okay, get previous node dot set next node. Whoa, hello. Dot set next node equal to cur node dot get next node. Make sense? That's a scary line. So that's saying go here, find his previous node, set his previous node's next node to this guy's get next node. So that makes this pointer no longer point here, now it points here. Make sense? Then we're going to say this guy's get his next node, set previous node equal to his get previous node. So that is cur node dot get next node dot set previous node equal to cur node dot get previous node. All right, and then the piece I like, which isn't required, I like to set cur nodes next and previous node to null. I want to disconnect both of these guys for completeness sake. And we see, though, after we've done that, that our list is still preserved. Okay, so I'll go ahead and just do those two quick lines. Cur node dot set next node equal to null. kernode.set previous node equal to null. Okay, and again, these are not required. That is a Lippmann personal preference that I expect all of you to follow. You don't have to. I will never take off points, but I really do think this is good programming practice. All right, so now it's clean as day that we see this guy's no longer attached to our list. He's hanging on by a thread, literally, from our little cur node. So before we're done, we want to go ahead and make sure we return that dude, but we need to also decrement count. So we're going to say this dot count minus minus, and then return cur node dot get payload. Make sense? Okay, so is that everything we had to change? So now we should be able to go into display in reverse, start off at tail, keep going as long as previous node has no null. One. Okay. Let's go to driver. So we build our list. Let's go ahead and display it, and then display it in reverse. Oh, one more. Yep. Oh, actually, we can do this even in a cleaner way. Oh, this will work fine. So there's our reverse, taking advantage of head and tail. All right, and then let's test our couple of things here. So we're going to say ll.remove front, then ll.display. Okay, so it used to have a 7 in the front, now that's been removed. Let's remove end. Used to have a 2 at the end, now it doesn't. Let's do remove add index 2. So 0, 1, 2, so the 5 should be gone. Yep, 5 is gone. Let's do an add index 2. So let's add a 13 index 2, and then let's display it in reverse to make sure our previous node also still works. All right, so this is 0, 1, 2. There's our 13, so that's forwards, and here's backwards. It's good. Okay, so I think everything seems to be functioning. All right. Man, no mistakes. Man, way better than last time. Wasn't I screwing up a lot last class?
Yeah.
Bad Thursday. All right. So now we want to move on to another data structure called a stack. Okay, a stack is based on a linked list such that it is a subset of what a linked list is capable of. Dangly preposition, but whatever. All right, so a stack is a LIFO, that is a last in, first out queue, like a stack of cards. So if I'm dealing cards out, the last card I deal is on the top of the stack. So if I were to always remove from the top of the stack, the last card I put out there would be the first card I'd remove. Last in, first out. That make sense? All right. So stack, well, here we'll just say supports. Supports 3 functions. 3 functions only. Push, pop, peek. Let's talk about each of these. Stack. Push, pop, peek. Push adds something to the top of the stack. Pop removes something from the top of the stack. Peek looks at the top of the stack without removing it. That's add front. That's remove front. This is get at index 0. Make sense? So, substantially simpler than what we've been dealing with. What we've written here so far is a very generic, fully featured, doubly linked list. With a stack, do we have to know about tail? No. We just have to know where the top of the stack is. So notice I put top in quotes here. Top is kind of like head, the front of the list. Okay, you can call it head if you want. You can call it top, whatever makes you happy. All right, so whenever we put something into the stack, we are pushing it onto the stack. That is adding front. Whenever we are removing something from the stack, there's only one way to remove something from a stack. That's with a pop. We are popping it off the top of the stack. Like that noise? Practice, years of practice. That and the ampersand. I can write one of those pretty well. It's good. So you pop it off the top of the stack and return the value. Okay? So that's remove front. And lastly, we have peek, which lets us see what's at the top of the stack, kind of just look at it without actually damaging the stack. Make sense? For homework, due on Thursday, create a stack implementation and test it that only supports these 3 things. I would encourage you to start a new class called stack. That is a collection of nodes, and it should support integers, just like our linked list has. But I would not modify your linked list. You can if you want. If you want to modify your linked list, it'll take you 5 minutes to do this. Right? Implement push as whatever you want to push on there, just call add front. Implement pop as remove front. And implement peek as get at bucket 0. That's all you're doing. But I would encourage you to write this fresh, taking advantage of your new skill set now, so you don't have this data structure that sort of supports 10,000 things. It only needs to support 3. Okay? This shouldn't take real long to write. And then test it by just pushing a bunch of things onto the stack and then popping them off and proving what the stack looks like. Make sense? Questions, comments, concerns, bribes?
So is the stack the linked list? Or?
Well, stack is a linked list, but we can't get something from the middle of the stack. We can't get something from the end of the stack. We can only remove from the front of the stack. So it's a limited linked list because of our rules. It only supports these three methods: add front, remove front, and get at front, get front. Typically called push, pop, peek. Make sense? Go ahead.
Did you put the linked list the way we had it done up on GitHub or on Angel or something, so we have that code?
Oh, come on. It's done.
Thank you.
You already have the link to the to my GitHub, right? So, see how easy that was? How convenient? All right. All right, so I'll see everybody on Thursday. I'll put this assignment up on Angel. Remember, Tuesday, today's Bible study. If you want free lunch, God and Grub, go to the cafeteria. You don't even have to wait in line. Just sign in. You get a free lunch. We usually sit there from like 11:25 or 11:30 until close to noon. Then we go down to the Luptech Terrace room or whatever, and it's actually a pretty good time. There's usually disco lights and stuff like that, but I encourage you all to come. All right, I will see you when I see you.